Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Today's problem is continuation of the previous two videos. The same problem, if you recall, this was a problem about one body moving in one direction, catching up to another that starts moving after some delay. And in the first video we derived this formula, which is totally correct. And in the second video we started to plug different numbers and we started to receive some solutions that we were not expecting. Some we were expecting, some we were able to explain, some were kind of phantom solutions. And it looks like there is way more to this than we discussed, so I decided to put another video. So once again, this is an axis, this is point A, this is point B, this is distance D, this is car V1, and this is car V2, and there is a delay to 0 when the second car starts moving. And in order to solve this, I suggest we will draw a graph. And to draw a graph, we have to know that when the body is moving along this straight line with the constant speed, we always, no matter what, we can say that the formula would be x0 plus vt. And the formula, this formula is a linear line, is a linear. This always would be when t equals 0, x equals x0, so the meaning of x0 for this formula is intersection with the graph here. And the meaning of v, that if we have alpha, then tangent this alpha equals v. So those are two things that we have to remember. If we have the body that moves along straight line with a constant speed, we always can say that the formula would be x equal x0 plus vt, and graphical representation of this formula would be this straight line. Notice that it's possible to have negative numbers here. It's totally possible to have, for example, this scenario. This would be -1, and this will go this way. And all that means that graph would be x equal -1 plus vt. And v may be, for example, 5 kilometers an hour, 5t. It would be -1 kilometer. What that means? That means at the beginning of the moment, the body is located -1 kilometer to the left. Of course, possible to have not only this, but to have negative speed. For example, we have this graph, and we say that it's inclined in this direction. The straight line. What that will mean? It will mean that it is still x0, and it may be anything. It may be some 10 kilometers. And then x would be 10 kilometers, and then this would be -3 kilometers per hour. And then this incline would be 3. Tangent would be 3. And of course, it's possible to say if this tangent is 3, then this divided by this would be 3, and we can receive this time when this will happen. When this body starting somewhere to the right of 0 coordinate will reach the 0 coordinate. So, no matter what is the movement, left, right, where it starts, the formula would be the same. x0 plus vt. Of course, it's all different for each particular case, and let's apply this formula, for example, to the first body. Again, we will put x, we will put t, and let's turn this like this, so it's easy for us to follow. This would be same axis, this would be point A, and it's only natural to allocate it this way, that A located at 0x. So x at 0, this point A. And this would be point B, and this distance would be D, so this coordinate would be D. And so look on the first formula. When t equals 0, the beginning of the time, x is 0, so this graph starts here. And it's very nice. And as time grows, so the first formula would be x equal v1t, and there is no x 0, and the graph would be like that. Okay? Now, with the second graph, it's a little bit more difficult, but not much, because the body doesn't move, and it doesn't move for some period of time until t0. So this graph is constant. This is sitting here no matter what time it is. It's sitting and idling and sitting and waiting until the moment t0. And after t0, it's again described with this formula. It's described with this formula, graphs become like this. And here they intersect, and this would be the time of intersection, and this would be the coordinate of intersection, if I continue it all the way to this axis. But the point is that this formula is described v1t, and this formula we don't know yet, because this formula would be x equal x0, we have no idea what this x0 means, plus v2t. So we at least know that v2t, but we don't know what is x0. So the goal is to find what it is x0 for this graph. Fortunately, this valid at every point on this line. In particular, it's valid at this point. So if we plug this t0 and plug this x into this formula, we will find out what x0 is. Because x at that moment is d. Right? This is a point where x is d. I'm saying that this point belongs to this line and to this line. Ignore this line, and it belongs to this line, and this is where x equal d, x0, and plus v2, and we know what time here, this is exactly t0. And so we can find d minus v2 equals x0, we will move it to the left, customary x0 equals d minus v2 t0. Notice d minus v2 0, it's something from here. Okay, so if this is the case, we know x0, we know that this is a formula at any moment, we can say that x equal d minus v2 0. It's all known numbers. D is known, v2 is known, t0 is known, plus v2t. And this is the formula that describes this line. So this formula describes this, and this formula describes this. And with your permission, I will remove this, because we don't need it. Because all we now need is this formula and this formula. This formula describes this line, this formula describes this line. Let's put them together. X equal v1t. Let's say that at one particular moment, and this is this moment, their coordinates is the same. So I can find this t if I get rid of x. Basically, v1 is known, d known, v2 known, t0 known, v2 known, two unknowns. One unknown is t, and another unknown is x. Those two things that we don't know in this system of two equations. Well, it's extremely simple to solve. Put it here, and we received v1, 2, get rid of x, plus v2t, move it all to the left, factor t out would be v1 minus v2 equal d minus v2 t0, divide into v1, 2, we'll receive the same formula. So it's very nice that using different methods we had received the same formula, but let's see how we can solve those phantom solutions or some known solution, maybe something else will come up from not only this formula, but this discussion. Because this discussion is even more generic than this. And notice, I didn't assume that v1 is positive, v2 is negative. I didn't assume that v1 is greater v2. Nothing. I just draw a mathematical expression for the graph of the first car. I draw this graph and I derive mathematical expression for this formula, for this motion. And basically that's it. And then I solve it. Oh, I forgot one little thing that I will add here. So remember, this is x0 for this motion. This is x0. So if I continue it here, I know that there is no motion of this car before t0, but this formula kind of describes that if the car would be moving with speed v2 forever, in such a way that at that moment it will be in b, and before it was still moving from here, then at the beginning of time this would be x0 and this would be d minus v2 0. And if you look on the formula, you will see that because this is d, that means that this is v2 t0, and if you look on this, it's exactly the true. The car would be moving from this point, it would be moving with the speed v2 for the period of time t0. You will cover this distance, so when this distance d multiply, v2 multiply v2 multiplied by t0, it will arrive at point B exactly in this coordinate, exactly in the moment t0, so everything is perfectly fine, which is good and nice to have. And in my next video, maybe it would be 2, I don't know, I try to be as brief as I can, but I am not a man of few words. So I will try to solve those cases and discuss those phantom cases using those graphs. And in the meantime, don't forget to subscribe, to click the button so you don't miss on the action, because I will publish more problems very soon. And thank you for visiting.